Scientists painted cows like zebras, and it worked. Somewhere in Japan, a cow was painted to look like a zebra. This is not a sentence that promises dignity. It is, however, science. The cow in question was not attending a costume party. It had not joined a very niche theater group. It was part of an experiment about biting flies, which are among nature's least charming inventions. Biting flies torment cattle. They land, bite, and make life miserable for animals that were already busy with the full-time work of being cows. The cows stamp, they flick their tails, they twitch their skin, they toss their heads. They become large, irritated, milk-producing windmills. This is bad for the cow and bad for farmers. Stress affects feeding, rest, health, and productivity. A cow that spends the day battling flies is not having a restful pastoral existence. It is having an argument with the air. Then came a beautifully odd idea. Zebras have stripes. One theory suggests those stripes help deter biting flies by confusing their landing systems. A fly approaching a striped surface may misjudge speed, angle, or position. In effect, the zebra becomes a visual problem the fly is too small and annoying to solve. So researchers asked the obvious question, assuming your definition of obvious is generous. What if we painted cows with zebra stripes? This is the moment when science becomes theater. A serious researcher, a bucket of paint, a Japanese black cow, and, presumably, a cow expression that said, "I had hoped for grass." The team painted bold white stripes on some cows. Other cows were left plain or given less obvious markings. Then they counted fly landings and observed defensive behaviors. This means someone's job, for a period of time, was to look closely at painted cows and count flies. Science is full of glamour if you know where not to look. The results were remarkable. The zebra-painted cows attracted far fewer biting flies than the plain cows. They also showed fewer fly-repelling behaviors, less stamping, less tail flicking, less irritated cow choreography. The stripes appeared to help, not because the cow had become a zebra in any biological sense. It remained fully cow, with cow thoughts, cow digestion, and the same general commitment to chewing. But visually, it had become confusing. To a fly, landing is not a casual event. It must detect the target, approach at the right angle, slow down, extend legs, and arrive without making a fool of itself. Stripes can interfere with that process. The fly approaches. The pattern shifts across its vision. The surface becomes harder to judge. The landing goes wrong. The cow, for once, wins a small argument with the universe. What makes this study delightful is not just that it worked, but that it is so visually ridiculous. Science often arrives dressed in complexity. Equations, machines, terms with too many syllables. But sometimes it arrives with a paintbrush and the expression of a person who has just realized the cow should be stripy. There is also a serious point. Farmers often use chemical insecticides to control biting flies. Those chemicals can be costly, may have environmental concerns, and can become less effective if insects develop resistance. If visual patterns reduce fly attacks, even partly, it opens the door to low-cost, low-chemical approaches. Perhaps not every farm will become a landscape of zebra cows. There are practical questions. Paint wears off. Labor costs matter. Cows may have opinions, although they tend not to file them in writing. But the experiment reminds us that animals live inside sensory worlds very different from ours. We see a cow with stripes and think, that looks silly. A fly may see a navigational crisis. Nature is full of these private realities. A flower that looks plain to us may blaze with ultraviolet patterns to a bee. A bird may see colors we cannot imagine. A bat can build a map from echoes. A shark can sense electrical fields. A fly, apparently, can be outwitted by making a cow look like it escaped from a barcode factory. Humans are very proud of our senses, but we occupy only one version of the world. Every creature lives in its own edited reality, built from the signals it can detect. The fly's world is fast, compound-eyed, and tuned to landing on things it can bite. The cow's world is slower, grassy, and, until the experiment, tragically understriped. The researcher's world is the strangest of all, one in which painting cows becomes a perfectly reasonable workday. This is why odd studies matter. They reveal hidden rules. The zebra stripe question sounds funny, but it touches deeper ideas about vision, evolution, animal welfare, agriculture, and how tiny brains solve movement problems. It also proves that science does not always begin with a solemn face and a giant machine. Sometimes it begins with someone staring at a cow and thinking, what this animal needs is a zebra costume. And, against all expectations, being right. If you enjoyed this strange little journey, subscribe and help us reach 1 million curious minds. There are many more weird facts hiding in plain sight, and we intend to bother all of them.